Welcome to Maths and Science by IITian. In this channel, we have released around 65 videos basing on different topics, and for the last 15 lectures, we have started talking about the complex geometry or complex numbers. We have spoken about the number system. From the number system, we have slowly drifted to complex number system, which is the biggest number system available. In the complex number system or complex analysis, 13 lectures are released on various types of the numbers, their geometry, mapping, and little bit of differentiation like Cauchy-Riemann equations and continuity. In this lecture, we will be emphasizing on complex geometry because there are many questions being asked either in IIT JEE Advanced or IIT JEE Mains regarding the complex geometry, complex numbers, complex algebra rather than complex calculus. We will be concentrating more on complex algebra, and for that we want to know the basics of the complex geometry. And once we know thoroughly about the complex geometry, then we will be able to switch over to our real number system. Now, complex numbers are nothing but like vectors. Addition is also like vectors, subtraction is also like vectors. I have already spoken about this enough in my complex number lectures and also on vectors. But still I will give a small brief. A complex number is a number is in a plane, complex plane. This is real line, x-axis. This is imaginary line, y-axis. And if there is a number z let us say, then this number is denoted by the vector O, and this point is P, means OP is the vector with magnitude OP, and direction is at an angle theta to the positive x-axis in the anti-clockwise direction. This is what is we have defined till now. Now, we are going to define what is a straight line. How we define a straight line in complex analysis? In the real numbers, we know y is equal to mx plus c gives straight line equation. But it's not that simple in case of the complex numbers, because complex number is not a single number like x and y. It's not a single number. It's a mix of both real and imaginary numbers. It's a mix of both imaginary and real numbers. For that, if here y and x are the locus, m is the slope, c is the constant. If we can get something like this by the rearrangement of the complex numbers, then we will be able to say that this is the equation for the straight line in complex numbers. Let us say, again let us draw this is x, real axis, this is y, imaginary axis, and let us say there is one point z1. There is one point z1 with x1, y1 as the numbers, and we choose another point z, that is for finding the locus. Then how a straight line can be defined by using the locus of z and the fixed number z1. That means the z and z1 are to be connected in such a way that their locus should form in the form of y is equal to mx plus c. That equation derivation I am not going into the details. I am going to write straight away the equation, and let us check up whether it is going to form y is equal to mx plus c or not. The straight line equation in complex analysis is z1, which is a fixed number, and this is the locus number z1 z plus conjugate of z1 z plus some number r is equal to 0. This is the equation which is going to represent a straight line. In a Cartesian coordinates, in real system, real number system, the equation is simple, y is equal to mx plus c. But in Cartesian or polar system, in both the systems, when it comes to the complex plane or z plane, the equation of a straight line is the locus of this equation, z1 z plus conjugate of z1 z plus r is equal to 0. Now, from our basic understanding of z, z is equal to x plus iy. X and y are variables. Even in y is equal to mx plus c, x and y are variable because we are finding the locus. Z is equal to x plus y, that is the variables. Z1 is fixed, that number is x1 plus iy1. Now, let us apply the values of z1 z in the equation given. This is the straight line equation. Whether it is a straight line or not, we will conclude. Z1 is x1 plus iy1 into z is x plus iy plus conjugate of x plus iy1 into x plus iy plus some constant is equal to 0. Some real number, constant. Then, what is the value of x1 plus iy1 plus x plus iy? x1x plus I into x1y plus I into y1x minus y1y. This is the value of this, plus conjugate of this value. Don't worry, we will write like this only. Conjugate of this value, which we have got here, plus r is equal to 0. That means we will make it like this: x1x minus y1y, this is the real number, plus I into x1y plus y1x plus conjugate of this. What is the conjugate of this value? x1x minus y1y minus I. You see, plus I will change to minus I into x1y plus y1x plus r is equal to 0. That implies x1x minus y1y this I value will go off. This is positive, this is negative. The remaining values are like this, plus x1x minus y1y, it is y. It is not y1 two times, it is y. y1y plus r is equal to 0. That implies here also it is y. That implies 2 into x1x minus 2 into y1y plus r is equal to 0. That means 2 into x1, x1x it is. Again I am making a mistake. It is only x. Now x into something, some real number, minus y into some real number plus r is equal to 0. This can be written as y into some constant or real number is equal to x into some constant or real number plus r. That implies y is equal to x into 2x1 by 2y1 plus r by 2y1. That implies r by 2y1 is a constant real number. So this 2x1 by 2y1 we will call it as m. This is in the form y is equal to mx plus c. Hence we have proved in the reverse direction. Z1z plus Z1z plus, either way you can write, no problem, plus Z1z conjugate plus r is equal to 0 represents a straight line in complex plane. If you see, the value of imaginary numbers vanished in this, and in JEE Mains or JEE Advanced, rather JEE Mains, the question can be asked, write the equation of a straight line and a point Z1 is given. Then this is how you have to write the equation of a straight line. They can ask what is the slope of the straight line by giving in the complex plane, by giving the Z1. Then you have to write like this. You have to find out. From this you can find out the slope. This is the slope. This is the intercept. This is slope. This is intercept. That means we can apply complex number rules are almost coinciding with real variable rules. We have taught real variable rules initially in our education. These complex number rules are the extension of the real number rules, and when you go back from complex to real, we will be eliminating the value of I, the coefficient of I, and we will be seeing that from complex we can easily switch over to real variables. Now, next equation what we require, I thought it is prudent to tell me, equation of a bisector. What is meant by bisector? Equidistant from, there is a line PQ something is bisecting it, some P dash and Q dash, some perpendicular line is bisecting, perpendicular bisector. Then PP dash is equal to QQ dash, which you know very well from your basic geometry. But when it comes to the complex geometry, complex analysis or complex numbers geometry or complex plane geometry, the equation is like this: Z minus Z1 modulus is equal to, or magnitude is equal to, magnitude of Z1 minus Z2. When this is the equation of the bisector, equation of bisector, which bisects the line Z1 Z2. Now you got the equation of the straight line, you got the equation of perpendicular bisector, and any question on straight line equation or perpendicular bisector, I think you apply these rules and you can easily get the answer. Best of luck to everybody. It's a small lecture. I thought it is prudent for me to give an introduction about the geometry of straight lines. Also, geometry of circles I have already explained. For example, Z is equal to 1 is a geometry of circle, locus of a circle, with origin as center and radius as unity. For example, if it is like this, Z minus 3 plus 4i is equal to 5. Can you find out what it is? Don't be afraid in the examination. Things will be like this only, very simple. Z can be written as x plus iy because it is a locus, minus 3 minus 4i is equal to 5. That means x plus iy, real numbers all will make it together. That is the only requirement that we have to do in complex analysis. Plus I into y minus 4 is equal to 5. This 5 is the radius and 3 is the x coordinate of the center and 4 is the y coordinate of the center. Whatever is given, x plus a is given, then x plus a make it to 0, then x is equal to minus a. For example, it is like this: x plus a plus I into y plus b is equal to r. What it represents? X plus a plus I into y plus b, x plus a plus I into y plus b is equal to r. In this, x plus a you make it to 0, that means x is equal to minus a. This is the center. Y plus b you equate it to 0, you will get y is equal to minus b. Y is equal to minus b. R you keep it as r only, so that for this type of representation, minus a minus b is equal to center and r is equal to radius. This is the locus of a circle. This is the locus of a circle. Its center as minus a minus b and r as the radius. That we can better write this way. This we can represent this way. Even though if we are making a rough diagram, let it give a real feeling. Minus a is here, minus b is here, this is the center, and this is the circle. So that this is the center. Minus a minus b. And from the center, this is the radius r. This is how. For example, in JEE Mains, they can give some equation in a complex and they may say which of the following figures will represent the what you call above equation. Then in that case you have to see x plus a into y plus b or something like that. Please see this, and it's a very simple one. And straight lines, circles I have completed in complex algebra. And best of luck to everybody. Thank you for seeing my lecture. Thank you for spending time for my viewing my lecture. I am from Maths and Science by IITian. It is my own channel. If there is a value addition because of this lecture to you, please share it. Share my channel to everybody you know and subscribe to my channel. I will give in the description the playlist link for all other 65 videos. Some quality videos I have made. Please see them and update your knowledge, and also please update me with your valuable comments so that I will try to improve with those comments in the next lecture. Thank you. Best of luck to you.